We are finding more and more exoplanets, more and more locations for liquid water, and the possibility for life as we know it. But where are the alien civilizations? Where are the technologically advanced creatures? Why can't we find signs of other sentient beings? Where are their signals out there amongst the stars? Perhaps the answer to that age-old question, are we alone in the galaxy, is a yes. American astronomer and astrophysicist Frank Drake established the search for extraterrestrial intelligence, or SETI, back in 1960. Listening to the stars and the noisy galaxy, trying to find signals that are deliberate, messages from other planets where life has evolved an intelligence, a technological civilization like our own, able to comprehend the vastness of space. Like us, looking for the answer to that age-old question, are we alone? There are 3,700 known exoplanets so far. NASA's TESS is going to find lots more. The European Cheops mission will specifically study the known exoplanets and look for more around our brighter stellar neighbors. Multiple planetary systems and terrestrial, Earth-like planets are coming up trumps, and we've only been looking for 15 years. We have been looking and listening for nearly 60 years now with zero results. No radio signals, no laser or other light flashes in our direction, no attempts at communication that we can detect. So where are all the aliens? Well, it's a complicated question. Stars that can harbor Earth-like planets, viable exoplanets that can sustain liquid water. As for life, how long does it take to generate life? Then, how long to evolve into intelligent life? Will that intelligent life become technological? How long will an advanced civilization survive? Tough questions when you only have Earth as your example. Then there is the time factor. The universe is 13.8 billion years old. Our star, the Sun, is 4.6 billion years old, and probably a third or fourth generation star. Earth is 4.543 billion years old. Our moon is just the right size to stabilize Earth's rotation and provide ocean tides and sea currents. Life on Earth is at least 3.5 billion years old. Several major climatic and asteroid interventions steered the evolutionary cart leading to us, Homo sapiens, 200,000 years. Our civilization began around 6,000 years. The industrial age is just over 200 years. The ability to send signals into space, maybe 100 years. Powerful radio signals, television signals, radar and laser light, say 50 years. Being generous, our signals have traveled out in a sphere with a radius of 100 light years. That's about 1,000th the width of the Milky Way, which is 105,700 light years across. The nearest galaxy is Andromeda at 220,000 light years away. How long will we continue to broadcast? In other words, how long will our technological society last? Some think not so very long. We have to be realists. There will not be too many terrestrial-like planets with liquid water and an atmosphere to support life, nurture that life to evolve over billions of years into a sentient species that may just develop technology and an understanding of the cosmos to want to listen out and respond to a signal from space. There is most likely life out there, but it's not talking to us yet. Let's crunch some numbers. We'll take the arbitrary figure of 100 light years, where a sufficiently advanced society could detect our radio signals. They then work out where the signal came from and dispatch a response. This could take a few years to achieve. Then that signal will take up to 100 years to get back to us. 100 light years in kilometers roughly equals 9 plus 14 zeros after it. What stars are within that reach? We're only looking at main sequence stars, ones that are stable and long-lived, moving through various stages in their lifetime of billions of years. So we have 3,868 stars to choose from, plus a few more very dim ones we haven't found yet. Exoplanet hunters have been targeting the dimmer, smaller stars called red dwarfs or M-type stars because it is much easier to detect planets around them. There are 2,026 stars of that class in our region. They have also been looking at the slightly larger orange K-type main sequence stars. Because of their spectral and luminosity qualities, astronomers favor them for having habitable Goldilocks regions. There are 947 and counting, though there are only 155 within 50 light years. Then there's the G-type stars. Our Sun is a G-type, so they are highly regarded for habitable zones. There are 512 of them. F-types are slightly larger than our Sun, 303 are nearby, and several have known planets. A type which are young stars, a mere 100 million years old, and again have been found to harbor Jupiter-like gas planets, 76. B-type are giant blue stars and rare, only 4 in our region. And supergiant O-types are hot and hostile and nowhere near us. So, how many exoplanets? 3,700 confirmed exoplanets so far. 5 Mercury-sized rocky worlds, 72 Mars-sized, 701 Earth-sized terrestrials. 982 called super-Earths, 799 Neptune-type gaseous worlds, and 1,217 Jupiter-sized gas planets. So that gives a current total of 1,683 Earth-like rocky planets. How many of these rocky worlds could harbor liquid water on their surface? Well, there is the habitable or Goldilocks zone around these stars, where the planets receive the right amount of solar flux, where water is liquid. Too close and the water would boil away. Too far and it will freeze, making life more difficult to evolve. So, scientists have estimated there are 17 definitely within this zone. But 3 are outside our distance limit of 100 light years, so that leaves 14. Plus another 13 terrestrials that could seed life, but be very harsh and unforgiving to it. That makes 27 candidates capable of harboring life as we know it.
Life could be incredibly common because there are lots of planets out there, or it could be an incredibly rare event that only happens, on 1 in a billion planets in a galaxy. We really just don't know. So whenever I get asked that question, my answer is, I don't have an opinion yet. I'll need some more evidence.
TRAPPIST-1, an M-type dwarf star at 39.6 light-years distance, contains a solar system of 7 terrestrial planets and is a major contender for harboring liquid water. They're all Earth-sized candidates. Other multi-planet systems in our region include HR 8832, 55 Cancri, and 61 Virginis. The names just roll off the tongue, each with at least 3 planets orbiting it.
Well, looking at exoplanets, these planets around other stars, is a bit like detective work. They're so small next to a bright star that it's hard to tease out information unless you do it incrementally. So what we can tell right now is that these planets are, in fact, similar to Earth in size, and we can tell that some of them may be similar to Earth in its composition. Doing kind of crude studies of the density of these planets. We're also using the Hubble Space Telescope right now to do follow-up observations of the atmospheres of some of these planets to see the composition of the atmosphere and wondering and trying to find out if maybe there might be water in the atmospheres to see if they are similar to our own Earth's atmospheres.
With names like TRAPPIST, Tau Cetus, Gliese 876, HD 219134, and Wolf 1060, these exoworlds sound ponderous and uninteresting. But one day they may be given more appealing names, because these are worlds with great potential. Elements such as hydrogen, helium, carbon, and oxygen abound throughout the universe, so we might assume that they are available to such planets, and therefore water would be plentiful. Even worlds completely covered in water are feasible. These basic elements also make up the active ingredients for life. And amino acids are commonplace, so microbial life could emerge on all these target planets quite readily.
Now, we strongly suspect, based on an example of one, our Earth, that the laws of biology work the same everywhere too. And by that I mean the laws that Charles Darwin discovered for us. We think that based on these laws, that evolution can drive life to greater complexity and ultimately to intelligence. It's the smart thing to do.
As with Earth, it could take billions of years for evolution to create ever greater complexity and eventually intelligence. On Earth, most highly intelligent creatures are of the mammalian family, but the octopus developed its intelligence through an entirely separate route. This would indicate that intelligence has many chances of evolving on these worlds. So, why are there no similar technological societies among these 27 candidate planets? What could be stopping intelligent creatures from developing technology, radios, and spaceships? There are several possible answers. Earth has had major climatic disasters that nearly wiped out life completely. Perhaps a similar disaster was successful on one of these other worlds and killed it. But even with these events befalling some of our candidate planets, there should still be 25 or more potential civilizations.
So, you'd think there'd be plenty of opportunities for life to evolve somewhere else and maybe swing by the Earth, or at least call on the radio. But we haven't found any alien monoliths, or beer cans, or cigarette ends, and we have not heard them tweeting on the radio either. So, where are they? There are lots of theories about that, but I'm going to concentrate on the more plausible ones. First of all, there's the water trap. Maybe the worlds that have water on them are all ocean, for the most part. And if that's the case, you can't discover combustion, you can't make metals, so you can't make a radio or a spaceship. If our dolphin friends lived on an ocean planet, they would be stuck where they are, in the Stone Age, forever. Or maybe on a planet that has dry land but no metals, or very few metals. Same problem, you can't develop a technology. And how about the difficulty of interstellar travel? Maybe it's just too hard. It looks like a real challenge for us. It could be a couple of 100 years before we try that. Maybe it's just too hard. And then there's another theory, which is that we could be the first. We could be the first intelligence to evolve in this part of the galaxy. Someone has to be. We could be the elder race. So here's a time history of Earth. When you look at all the time that life has been here, nearly 4 billion years, humans have only been around for a couple of 100,000 years, civilization for about 6,000 years, depending how you count it, and our technical era only for 200 years. When you look at this picture, it is obvious that the most likely first alien life forms that we discover will not be intelligent. They will be somewhere back here, equivalent to life on Earth during the first 3 billion years of evolution. Similarly, nearby life on an exoplanet is probably plodding its way up the evolutionary ladder. Remember how long it took us to get where we are, where we could even think about life elsewhere.
We Earthlings have the prime real estate in our solar system. We may well be alone for the moment in our section of the galaxy, the only ones with space travel. If so, we need to take care of our planet and our civilization, and stick around long enough to see other intelligences and civilizations emerge over the coming millions of years on those 25 nearby planets.